All right, hello everybody. I hope you have your notes out. Um, we are going to go through the process of doing long division with polynomials, and what I have on the screen right here is an example of how to do long division with just regular numbers. We're going to review the whole process really fast, and then we'll look at some examples in our notes. Okay, so in this number, or in this equation, you have 4,785 divided by 9, and you first try to see if you can, how many times you can divide 4 by 9. Well, you can't divide it a single time, and so you're going to carry down the 4 and the 7 down here, and so then you are going to look at this number and say, okay, how many times can I divide 47 by 9? Well, most of you know that 7 times, not 7. Most of you know that 9 times 5 is 45. And so you'll take this number, you'll put a 5 up there and do 5 times 9 and give yourself 45. Okay? And then hopefully you remember that this is a positive 45, but when you're doing long division, you don't add the two numbers together. Whoa, that's a very big line. Sorry about that, guys. So you don't add them together. What you do is you subtract them. Okay, so every time the process here, you're always going to subtract. So you have 47 divided by 45, and you get 2. Well, and you might ask yourself, how many times can you divide 9 or 2 by 9? Well, you can't, so you carry down this 8. Then you say, okay, how many times can 9 go into 28? And most of you know that, let's see, 3 times 9 is 27, right? I'm doing that math in my head, and look, I was right. All right, so 9 times 3 is 27, and again, you're not adding those two together, you're subtracting it. And so you carry down, and then you get 1, whoops, and then you carry down the 5. Let me move that down a little bit. All right, and you get 15. How many times can 9 go into 15? 1 time, and then 1 times 9 is 9, and again, you're subtracting, and you get remain a 6 is left over. Okay. Now, depending on what grade level you were, you might go ahead and go into decimal points here and drop down a 0.0 and then keep on going forever and a day. But when you first started doing long division like this, anytime you had a remainder up here, you would just put down like an R for a remainder of 6. Okay. Now, when you're in college, pre-calculus, and if you ever go into calculus, they will do extra stuff with the remainder, but for now, just write the remainder up there. We really don't care at this point what the remainder is. We just want to know how many times can 9 go into 400 or 4,785, and the answer is 531. Okay, hopefully you remember about this process and you remember that down here you're always subtracting, okay? So now let's look at an example with a cubic function here. This is our polynomial, and we want to factor it. And I know in your notes you have the example already set up for you, and it takes you through factoring the x plus 1 from this equation. Well, where did they get the x plus 1? Let's say you have a calculator and you're graphing it, and you want to find at least one x-intercept. Well, we know right here that this x-intercept is -1, but this one is not on a tick mark, and neither is this one on a tick mark. So we don't know what's going to happen or what exactly these where exactly these x-intercepts are. So we want to find out, okay, if one of my factors is, let's say, because we have an x-intercept at -1, then it would be x minus -1 or x plus 1. Okay, so if that's one of the factors, what is going to be left after you factor out the x plus 1? Well, that's why we do long division, is to see what's left. Okay, so now we've got our first factor, x plus 1. Whoops, and when I erased that other stuff, I showed you some of the answers. Hold on, let me just unerase this and get rid of all this stuff. All right, sorry about that, guys. All right, so now this is what the scenario of why we have or where we got the x plus 1. That was one of the factors we found when we graphed it, one of our x-intercepts, okay? So now we're going to say, okay, we have x cubed. How many times can x plus 1 go into x cubed? And initially you're like, what the heck is she talking about? X plus 1 cannot factor in or can't divide in x cubed. Okay, so what I'm going to tell you now, do not worry about all this stuff out here. Just look at your first term here. Maybe it's x squared, maybe it's x, or maybe it's 2x, whatever. It doesn't matter what it is. We don't care about this right now. We just are focusing on this, okay? So now instead of saying how many times can x plus 1 go into x cubed, just say how many times can uh, x cubed be divided by x? Or in other words, what can you multiply x by to get x cubed? Well, if you multiply x by x squared, oh, that's not what I want to do. Maybe, hold on. Yeah, if you multiply x by x squared, then you get x cubed, right? Okay, so now your next step is to say, okay, we have x squared times x, we are going to get x cubed, okay? And then, but then because this is not just an x here, because you have x plus 1 here, then you have to also say, okay, what's x squared times 1? So notice we're multiplying both x, and 1 by x squared. So very similar to our long division with our other numbers, but because we have two terms here, you're going to have to multiply both terms by whatever you have up here. Okay, so that x, so because you're multiplying this by x squared, you have x cubed plus x squared. And remember, with long division, we're subtracting everything. So imagine that there's parentheses out here. It's a terrible parenthesis. Sorry, imagine that there's parentheses out here and you have a negative sign out. So instead of adding these two terms, we're going to subtract the two terms. Okay? So what happens is that instead of x cubed plus x squared, we have negative x cubed or minus x cubed and minus x squared. Okay, well, and then these two cancel out and you're left with 5x squared minus x squared. And I don't know if that's the right one. Hold on. Let me see. Nope. Oh, I know what I did. All right, sorry. You get 4. I'm trying to deal with all these erases. Okay, so you get 4x squared is left for 5x squared minus x squared leaves you with 4x squared. You bring down then this next term, negative 5x, okay, and you're going to do the whole process again, okay? So what can you multiply x by to get, instead we're not just looking up here, we're looking down here. So what can you multiply x by to get 4x squared? Well, if you multiply it by 4x, 4x times x is going to give you 4x squared, okay? And so, and then what you're going to have is 4x and 4x squared, excuse me, plus 4x, okay? So 4x times x gives you 4x squared, 4x times 1 gives you 4x, okay? And then remember you're subtracting instead of adding. So our signs change, and now we have negative 4x squared and minus 4x. And what happens there? Let me get this one down. Okay, and then what happens here is you have negative 5x plus negative 4x or minus 4x gives you negative 9x. Bring down the negative 9. Okay, and this time right here, what do you multiply x by to get negative 9x? Well, you're going to multiply it by negative 9. Okay, so negative 9 times x gives you negative 9x, and negative 9 times 1 gives you negative 9. And then most of you look at that and say, okay, what's up with that? Now we have two negative signs. What do we do? Well, okay, Do the little parentheses again. Remember, we're subtracting here. So everything gets subtracted. And because of that, this negative 9x minus 9 becomes positive 9x and plus 9. Okay, and then that just equals out to 0. And in this case, we don't have a remainder. Okay, so now when I say, okay, if you factor out an x plus 1, what's left? You get, well, what's left is x squared plus 4x minus 9. And so we can say that the terms or the factors of that equation are x plus 1 and times x squared. Let me draw my x's. I'm not very good at drawing x's with my mouse pad. Plus 4x minus 9. Minus 9. All right. So that's what happens when you factor out the x plus 1. Okay. All right. So there we go. Let's look at one more example, and I'm pretty sure this is in your notes. In this one, in the center, it says, by multiplying the factors, we know that 2x minus 5 times x plus 3 equals 2x squared plus x minus 15. Show using polynomial long division that 2x squared plus x minus 15 divided by 2x minus 5 equals x plus 3, and that the 2x squared plus 5 minus 15 divided by x plus 3 equals 2x minus 5. So what you're doing here is you're just taking both of the factors, dividing your original polynomial by one factor to get the other factor, and basically switching places and seeing that it works both ways. No matter which way you start, no matter which factor you start with, it's still going to work. Okay, in this case, we're dividing by 2x minus 5, and you multiply that by x to get 2x squared, and you'll have negative 2x squared minus 5x. It gives you, all right, notice especially right here when you have a positive up here, don't forget that this ends up adding here. Okay, most people, if you're going to make mistakes, this is where you're going to make it, right here. See how you have a minus sign here, and you forget that this is a subtraction sign too, or a negative sign, so you're going to end up adding there. So 5x plus x gives you 6x. If you, how many times, what do you have to multiply 2x by to get 6x? Well, you multiply it by 3, gives you 6x minus 15. And again, notice the minus sign here changes it to a positive. 15 plus 15 gives you 0. Okay, same thing over here. The only way you can, or these can be factors of your polynomial here, is if you have a 0 down here at the end. If you have a remainder, it is not going to be a factor. Okay. All right, so that's long division. We will do lots of practice problems in class. Please, please, please watch this video. Get a basic understanding of how to do long division, so that you're not totally clueless when we're working through the practice problems, okay? All right, I will talk to you in class tomorrow. Bye.